Alright folks, ladies and gentlemen, this is my last video for this semester. Anything I do after this will be to answer questions or do some cleanup. So I think, oh God, I hope and I think that I left you with this problem. Starting from benzene, I want you to go through a multi-step analysis and end up here. If that's not what I put, well, fuck you, you should have read my mind. All right, so here. Now, again, what you should do in these situations is look at the end product and look at what the attachments are. In this case, these things are meta to one another. And the attachments are an I and a CH2 NH2. So, the iodine here, hopefully you can all recognize, is an ortho-para-director, as is the CH2NH2, although it's really weak. The thing I would like you to take note of here is you know how to iodinate a ring. In fact, you know a couple ways. You know how to put on a CH2NH2? I didn't think so. So the question is, how do we do this? How do we go from something and make a CH2NH2? Well, let's answer that question. The key feature here is the fact that you've got a carbon and a nitrogen. All right? A carbon and a nitrogen. All right, so now, do we know of any linkage that can give us a carbon-nitrogen bond in any form? Now, this is the point where you've got to take a little bit of an intuitive leap and go, CH2NH2, no. What about C triple bond N? I know how to do a few things with C triple bond N, and this could possibly work. So why don't we try that? So now the question, well, the reason this works is the C triple bond M is a meta-director. That works to your advantage here. So now the question is, do you know the way to put a nitrile onto an aromatic ring? Yes, you should. It's in the reactions we've covered. You kind of have to go around Robin Hood's barn for it a little bit. But here's how it would work. Starting with benzene, we go to nitrobenzene. Using nitric and sulfuric acids, you get nitrobenzene. Reduce it with tin and HCl. You get the amine, in this case, the aniline. Nitrous acid will put you here. At the diazonium salt. Whoops. At the diazonium salt. Now, add copper 1 cyanide, and you get here. Now, that is benzonitrile. And one of the things I hope you remember about benzonitrile is this is a meta-director. So what's our other group we have to put on here? I think I picked iodine. So how do we iodinate this ring and have it go meta? Easy. You just iodinate the ring. Iodine and nitric acid. Now, some of you out there may be thinking to yourself, cyanide looks like this. Wouldn't that have a chance of picking the proton off of the nitric acid? Well, maybe, but it's not as good as, say, a free NH2 is at doing that, thinking back to our previous example. So this, you don't have to worry about it picking up a proton and suddenly becoming a confusing metadirector. Instead, it's going to behave itself, and you're going to get your iodine here. Either meta position is fine. And now the last question, how do we go from this C triple bond N to a CH2 NH2? How do we do this? Lithium aluminum hydride, ladies and gentlemen. Now, I've taught you some tips and some tricks. You're really overwhelmed right now because you've got finals. A lot of you have to move out of your off-campus housing because all of the realtors in this town are assholes. You feel overwhelmed with all your quizzes and exams and homework and everything coming. Folks, we're done with new material. We were done with new material earlier this week. I'm not introducing any new reactions. What we are looking at are ways of using some of the reactions that we already have at our disposal. All right? So the number one piece of advice I can give you guys is don't panic. Seriously, it's not worth it, guys. You've come this far. You've done amazing things. You're all wonderful. I have so much faith in this whole class. So, what I need you to do, though, is not panic about this stuff. Second point I need you to do is do your toolkit. I know a lot of you are seeing this toolkit as this punitive thing that suddenly I made into points. Folks, doing your toolkit is going to help you study for your final. It's not a punishment. It's not this random shit that I'm throwing at you. Trust me, this is one of the best things you can do for the final. Quick reminder of the constituency of the final. It is 100 points. 60 of those points is going to be fill in the box. All right? Is going to be fill in the box. What does that mean? Well, it's like A plus B yields this. Or it could be A plus blank yields C, or blank plus B yields C. Any of those are a possibility. 60 points is going to be that. 20 points is going to be mechanism. While I have not made the final yet, I can tell you that what I'm very likely to do is find 20 points of mechanism, say, okay, 4 at 5. I'll give you 8 options, pick 4. That way, now you don't know what my 8 options I'm going to give you are, but that way there's a lot of choice in there. That if you just miffed on something or you panic and freeze, you have other options. Finally, 20 is multi-step. 20 points is multi-step synthesis, okay? So a lot of like what we're doing, and it can cover any of the reactions from Organic 2, but if you know the reactions from Organic 2, you already know the ones from Organic 1 anyway. All right, guys? So remember that we've gone through this together. I love you all, and you'll do fine.